Natural physics is a concept astrophysicist Leroy Larry developed that explains in down-to-earth scenarios how the principles of physics could have come about from observing nature. Each episode begins with a scenario, followed by an example to illustrate the application of these principles in futuristic research at the frontiers of science, such as Leroy's astrophysics doctoral research at CNESPA, Center for Space Research, and then concludes with an exploration of how these same principles could have very well been used by ancient cultures and civilizations. Mathematics is naturally encountered and incorporated as the exciting and fun tool of science that it is. Science is the window into our amazing world of nature, and mathematics is the tool to open that window. Natural physics encompasses current, futuristic, and ancient physics, and ties them together by the principles of physics that are common threads running throughout each.
Greetings, I'm Leroy Larry and welcome to Natural Physics, live from Costa Rica. I hope everyone had a happy and safe Halloween, All Hallows Eve. And as I stated, as not with the other events such as the summer and winter solstice and the spring and fall equinox, which are tied to the movements of the earth with respect to the sun, All Hallows Eve comes at the end of October. And I just wonder, where does that correlate in nature as do the other four events that I just mentioned? Very interesting. Very interesting. Okay. As previously announced, we have been invited to the inauguration of the Baduka Indigenous Community Museum, located in the village of the Baduka. And I showed pictures that the director of the museum sent, those beautiful pictures of the museum and how it's been renovated. I found out from the director last week that there will be an internet connection at the museum on December the 15th. The inauguration. Now, if you recall, we would not have been able to broadcast live from those two spheres oriented east and west at Farm 6 because there was no internet connection out there. But here we will have the opportunity to broadcast our show on December the 15th live. Thank you so much, Ray. Right on. Now, hopefully, part of that inauguration event will be my giving a presentation to the Baduka community that I would have done last month on the fall equinox, but that got postponed, as we all know, because of COVID. Hopefully, that will not interfere this time. And I've been thinking about what kind of presentation could I give to the Baduka community? I mean, what would be a benefit with our endeavor to help them reclaim the ancient knowledge of how the spheres were used? What kind of presentation should I give? And I actually started thinking about the presentations that I gave in Nigeria. And these were presentations that were at a basic astronomy level, and they addressed basic questions that anybody would have. And I thought to myself, I wonder who has even bothered to give a presentation to the Baduka community, right? As unique as they are, I wonder if any organization or any group has bothered to talk to them. Just talk to them, right? So I thought that perhaps the presentations I gave in Nigeria, that might be a great place to start. Because as I've said, I intend for this to be a continuous dialogue with the Badukas, right? Them get to know me get to know them. And so what I thought is that now I don't know if this presentation will need to be given in the open air or we will have some type of a room, but I have an idea of my initial presentation to the community. And so what I'm going to do now is I'm going to go to screen share, and I'm going to tie in my idea of how to give that first presentation to the Badukas on December the 15th. Okay, so I'm going to go to screen share. Oh, yeah, let's go to screen share because there's some things I want to say. Okay, let's go to screen share. Okay, so share. Okay. Okay. Okay, so the first thing I would like to do is okay, here we go. Now, Ray, let me know if everybody can see this. Thank you. Thank you. That's such an awesome way to find out if everything is cool. Applause. Such positive, joyful energy. Okay. Now, when I was a professor at the University of Costa Rica teaching physics in English for the first time, actually, in the history of the university, there was a conference here. It was the United Nations Costa Rica workshop on human space technology. And I was lucky enough to get to go to it. I mean, I was right here, right? I was here in Costa Rica teaching at the university. Didn't involve any kind of a buying my plane ticket or accommodations or anything. So I had the opportunity to attend. And it was my first time hearing about the United Nations Office for Outer Space Affairs, UNOSA. I had no idea that the United Nations was at all involved with outer space. But yeah, I go to this conference, this workshop, and I listen to these talks, and they were very interesting from the different areas of human space technology involving going to outer space. And as I listened to these talks, I noticed that one of the themes that ran through a lot of the conference was outreach, how to communicate to not only developing countries, but developed countries about the benefits that the spinoffs from human space science and technology can bring to countries all around the earth. They were trying to find a way to communicate that to the different countries. And I thought to myself, hey, I've always done outreach, right? Maybe the way I do outreach could be of benefit. Okay. Oh, I started getting really jazzed. And at this conference, I met a woman from Nigeria. Okay. Her name is Amawumi Alabi, Dr. Awamumi Alabi. And at that time, she was the chief scientific officer, the head of the Space Education Outreach Program for the African Regional Center for Space Science and Technology Education in English, which is affiliated with the United Nations, okay? I mean, head outreach educator for Nigeria. And I told her about my idea of natural physics, of how I communicate physics to people, young and old, no matter the background. And she thought it was an interesting approach, and she wound up inviting me to Nigeria because she was going to have this workshop for teachers, for primary and secondary teachers in Nigeria. And she invited me, not right there at the conference, but we kept in contact. And I'd say about a month later, she invited me. Okay. So this is the flyer for that workshop. And I'm going to hide this so you can see the date of this. Yeah, this was back in 2016 because that conference here in Costa Rica, that was March of 2016. And so I get invited to go to Africa, right? I mean, I think I've touched upon this in season 1, but here I'm going to go into a little bit more detail. Ray, I'm going to apologize ahead for going over, and let me try to get to the video as quick as possible. So she invites me to come to Nigeria, and I am to be the invited guest speaker and professional trainer for the National Workshop on Astronomy for Teachers, which was designed to promote the teaching of science, technology, engineering, and mathematics, or STEM, by introducing astronomy in a simplified and readily comprehensible format to primary and secondary school teachers in Nigeria. Okay? So, my task given to me by the organizers of the workshop was to come up with presentations that would answer the 5 basic questions of: where is outer space? How do we view outer space from the Earth? How do we get to outer space? Once we get there, what's in outer space? And when we're there, how much do we find that the environment of outer space differs than the environment here on Earth? So that was my task. And I was to give these presentations in a way that would not only educate the teachers about astronomy, but would also excite and motivate them to want to teach astronomy in their classrooms, right? To go back to their respective schools and start an astronomy club, or start teaching astronomy after classes, or something of that sort. And the organizers informed me that this workshop was the first of its kind in Africa. I mean, we're not only talking Nigeria, we're talking Africa, right? Okay. So again, Dr. Alabi, she organized this workshop. And let me just say, going back to our last episode and how we talked about how women have been so excluded, okay, like a witch hunt, like you'd have witches in Halloween where they were just excluded. She had a lot of obstacles of getting this workshop done. I mean, she had to deal with some serious, unreal, unnecessary negative energy, but she got it done. So she invites me to come to Nigeria. And I arrive in Nigeria on June the 19th. Everybody who was with us in season one, you remember how around about June the 19th and July 4th, I talked about the significance of June 19th with respect to slavery in the United States. So for me to, hey, I probably don't need to say much, do I? For me to arrive in the motherland in Africa on June 19th day, I mean, I was overwhelmed. So, uh, this workshop, um, a quantitative assessment was done before and after the workshop, and it indicated that uh, the teacher's knowledge of astronomy had increased across the board, in some cases by as much as 100%. Um, the video that I will show, there was a question and answer section that you'll see. I showed a little bit of it in addition to my presentation to the teachers. But I just want you to know that on the side, I had a teacher walk up and ask me, now this is a high school teacher, ask me, why does the sun go across the sky? Why does the moon come up at night? This is a high school teacher in Nigeria. At the other end of the spectrum, I had a teacher ask me how could uh, her area of microbiology fit into astronomy, and I told her about the area of astronomy called exobiology, where you study organisms that could possibly survive in outer space, and how they're here on Earth. There's extremophiles, organisms that can exist in very, very extreme conditions here on Earth, at the bottom of the ocean, at the heat vents that exist at the bottom of the ocean. Um, isn't it amazing that nature provided organisms that can survive pretty much the same conditions that would be possibly in outer space? So the video I'm going to show is my first presentation to the teachers in Nigeria. And I really think that this would be a good presentation to show to the Baduka community on December the 15th as part of the Inauguration Museum. I would appreciate any comments that you have, yay, nay, but when you think about the spheres and how they are connected to outer space in tracing the movements of the moon and the sun, okay, heavenly bodies located in outer space, you wonder how the Baduka perceived of outer space. So this presentation that I geared to give to these teachers in Nigeria about where is outer space, I think I could do the same thing on December the 15th to the Baduka community, because it's at that level. I mean, it's one of the first questions you would ask. Where is outer space? Before you get to what's out there or how is it different from here on Earth, I think that would be the first question. Where is it? I mean, it's so obscure. So the video is going to show my presentation to the teachers in Nigeria. At the end is a little sampling of the questions that I got that I hope I will get the same from the Badukas. And I think I will, actually. because it's at that basic level, just that human inquiry of what's out there, right? What's out there? Using the spheres to connect to what's out there. Okay. And right before the video starts, there's some pictures that you'll see. Um, I want to say that uh, the woman who invited me, she's in one of the pictures. She has a red sweater on, Wumi. And then another person you'll see is he's the head of the Department of Physics at the Federal University of Technology, Akura. The workshop was held on the campus of FUTA, F-U-T-A, Federal University of Technology, Akura. And this gentleman, we talked about the possibility of me coming there and joining the faculty. Can you imagine me in Nigeria, Africa? Oh, huh? I don't know. I that would have been I don't know because the culture is cool, but it's very different. And Tirza, I don't know if she would have rode with that, but we talked and we kept in touch. And because they didn't have a department of astrophysics, I decided not to join the faculty. They had a faculty, they had a department that dealt with solar energy and how to practically apply that to human power. Hey, survival, right? Again, survival. But they didn't have anything in astrophysics, so I politely declined. And his name is Kunle Adalji. Okay, you'll see him. Okay, so I think we're about ready for the video. Oh, one thing I wanted to say is that I was told afterwards that I was playing to a rough crowd, meaning that they had been known to boo presenters off the stage. I'm sure glad I didn't know that beforehand, but that's what I was told. And I got to tell you, you'll see at the beginning of the video that it just occurred to me to find out how would I say and this is something that I would apply to the Baduka community. Okay, I found out how to say good afternoon in the dialects of Nigeria, which at that time, 3 main dialects. So I wrote down on a piece of paper how to say good afternoon in all 3 dialects. And I think that's how I won them over from the jump. You know, it was a lesson to me. Just doing something human, right? Wanting to say hello, but wanting to say it in the language of where you're at. Showing that courtesy and respect to do that, right? It's just a natural thing, like natural physics. Okay, so I think we can get to the video now. Let me make sure. Oh, one other person that you're going to see in the video, his name is Professor Joseph Akinyere, and he's the director. This is the invitation letter that I received to invite me to Nigeria, right? You know I've never gotten an invitation letter to no nothing, honey. So, and he's the director of the Center for Space Research and Applications at the Federal University of Technology at Akura. Okay, you will see him introduce me in the video. And you know what, Ray? I know we're going over. I'm so sorry, but I got to do this. Okay, I'm going to go back to this. Everybody, I want you to know that before I went to Nigeria, the only experiences I had with that country, first time was in high school. My biology teacher. Remember I said how way back in the galaxy, a long, long time ago in a galaxy far, far away, in my high school, sophomore year, your second year of high school was when you got biology, and then you got chemistry the next year. And then my high school offered physics. Luckily for me, offered physics my senior year. But my sophomore year, biology, Mr. Bangura, Bangura. And and his accent when he spoke was so cool to me. You figure I'm 15, right? This is about the same time I read the book Guys from Outer Space. Remember that I talked about before, season 1? So I remember his accent. Leroy, Leroy. No, 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 Leroy. You, no, no, Leroy. No, 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 not, no, Leroy. Do better, Leroy. He was rough. I mean, he was no joke, right? And and the second time I encountered Nigerians was of a whole different ilk, and you know I want to use that word. I was a sophomore at Southern University. I'm sorry, I was a senior at Southern University in Baton Rouge, Louisiana, historically black university, and I had majored in physics, and you have to take so much math when you major in physics that you may as well minor in math. So I was taking, this was the last mathematics class I took as an undergraduate before I would continue on to my master's degree in physics at Tulane University in New Orleans. So this class was partial differential equations. Remember how I said equations are all we have until somebody comes up with something better or different to describe the amazing wonders in nature? So this class was partial differential equations, and there was these. When the class started, there was about 10 people in the class, but by the mid semester, there was only 4 left in the class: me and 3 Nigerians. Excuse me. And the professor, his name was Dr. Means, Means. Means, right? I've never seen a professor start a mathematical equation on one end of the blackboard and go all the way around the room and come back around with the same equation. Unreal, unbelievably difficult class. Anyway, uh, at the halfway point, and we got to get to this video. At the halfway point, there was only 3 of us in there, 4 of us. So as finals approached, one of the Nigerians came to me and said and invited me to join their study group as they prepared for the final. And I said, "Wow, that's cool, thank you." But I said, "You know what? And you know what, Ray? If we have to cut off when we start the video, if we have to cut it off at a point, we can do it. I'll just continue the next episode. But I think this is important for everybody to know. This was my uh, image of Nigerians before I went there. So I asked this. Oh, and by the way, these 3 Nigerian students were graduate students in mathematics, right? I was an undergraduate in physics, taking basically, I guess, a graduate level math class. Anyway, I asked him, I said, "Well, hey, it's been the 4 of us in this class for the last half of the course. Why are you just now coming to me to, to ask me to join your study group? I've been here all this time." Okay, everybody, this is what he proceeded to tell me, and in a very serious way. I mean, he wasn't joking. He was serious. He proceeded to tell me how when he was growing up, he had been taught that African Americans, blacks, African Americans, all the stereotypes you would ever expect to see in any Hollywood movie or whatever other thing, that African Americans are lazy, don't trust them around your money or your women. Huh? Right? I mean, right? I don't even have words for that. Okay, so this is what he told me. And I'm trying not to cringe and just get totally disgusted, maybe hurl, throw up on the spot. But I take it as he's telling me all this. Every negative connotation that's ever been attributed to African Americans, propagated by you know who. And that's what's going on in the United States right now. Okay, So after I listened to this, I proceeded to tell him that, well, you know what? When I was growing up, I watched these Tarzan movies, right? And they portrayed Yah, my uh, relatives. They portrayed Yah not as having the magnificent, beautiful modern cities that you have in different cities of Africa. No, you were portrayed as running through the bush with a loincloth on, with a bone in your nose, a plate in your lips, saying ooga, ooga, ooga. That's what I saw on the television. Now, for me to have believed that is just as bad for you to have believed what you were told. You see how fragile intelligence is about what you really know. Okay? Okay, we're going to get to this video. We're going to go over, but everybody, I apologize, but I want to give this introduction to this video. It kind of tells you where I was as I gave this talk to these teachers, the thoughts that had went through my mind, right? As a distant cousin to my relatives, who by virtue of their ancestors being snatched up from their lives and dropped down in a foreign country, we're related. Okay, Ray, I think that's all I wanted to show. Okay, yes, please, let's get to the let me find you again, Ray. Where are you at, Ray? Okay, I think I need to go down here. Oh, one thing I want to show, I'm glad. The presentation that I give to the teachers, this is it. Okay? And I just want to show you real quick that because this was a resource material for the teachers there, in every slide are my notes of what I said verbally during my presentation. Okay? So and again, all 5 presentations that I gave, and let me just show this. So basically what I did for the teachers, the first presentation was Where is Outer Space? I just basically started from the surface of the earth and just went up. Just talked about the different levels before you get to outer space, okay? Okay, and then I started talking about the solar system and just further out into outer space to try to give them an idea of where outer space is. And I don't think this would be a bad place to start with the Badukas, right? Let them see what current science thinks about outer space and go from there. Okay, so I'm going to close this and let's get the screen share. Okay, so I'm going to stop screen sharing, Ray, and if you could get to the video, that'd be great. Thank you. Okay, this is just pictures of me giving my presentation. Oh, this is so cool to be able to do this with the slides. Okay, and okay, there's Wumi, the woman who invited me down to Nigeria. You got the chancellor, Joseph, all these high ups. Okay, there's all the teachers, huh? Primary and secondary school teachers from all over the southern part of Nigeria, not the northern part. Akin Alamigoke, such a cool kid. Student teacher, I will tell you more about him at length. Okay? And this is the director of the Department of Physics, who I considered getting a job in the physics department. I'd be in Nigeria right now. Okay, here goes. Okay, here we go.
Ina ini. Indewu. Ekasan. Good afternoon.
I got him at that
point. It is my privilege and honor to be here. My mother was a teacher in Omaha, Nebraska, which is where I'm originally from, in the middle part of the United States. You have the greatest job, the most important job in the world, in my opinion, because you work with our future. No matter what country you are from on this planet, our children, our students are our future. And that's what you work with. So it is my honor to be here, and I will do my best during my presentations to tell you about astronomy and to excite you, encourage you, and motivate you about astronomy so that you will go back and do the same for your students. If you have any questions at any time, please let me know. If you cannot hear me well, or you don't quite understand what I say, please let me know so that I can correct that. We're going to be addressing 6 questions during these presentations. Where is outer space? How do we see outer space from Earth? How do we get there? What's there when we get there? How is it different than conditions here on Earth? What is in outer space? And then the final question, which actually I'm going to ask you to help me to answer this question. Why is it important for school children in Nigeria to learn about outer space? So let's get started. Where is outer space? And I thought, how do I answer this question? It's kind of an abstract concept, and my best way of thinking of how to go about this is to try to give you an idea of how big outer space is. Okay. At 100 kilometers above the surface of the Earth, we officially enter the realm of outer space. 100 kilometers. So let's start from the ground and travel up to get to outer space. The lowest layer of the Earth's atmosphere is the troposphere. It's from the surface of the Earth to about 12 kilometers above the Earth. The troposphere is where all of our weather takes place. Thunderstorms, clouds, wind. And as you go up into the troposphere, it gets colder because all the heat in the troposphere is from the surface of the Earth, absorbed from the sun. So the further you go up, the colder it gets. Airplanes that use propellers, this is the area of the atmosphere that they travel in, from 0 to 12 kilometers. Okay, let's keep going. Now we're in the stratosphere. Oh, sorry. Okay, so now we're in the stratosphere, which is from about 12 kilometers to about 55 kilometers above the Earth's surface. The stratosphere is different than the troposphere. There is no weather because conditions are stable, there's no winds, and the temperature is the opposite to what happened in the troposphere. Remember, in the troposphere, it got colder. Well, in the stratosphere, it's the opposite. The further you go up, the hotter it gets because of ultraviolet radiation from the sun. Jet-powered airplanes can travel in the stratosphere. The top of the stratosphere, the pressure is 1/1000th of the pressure on the ground. 1/1000th. The ozone layer is in the lower part of the stratosphere, from about 12 kilometers to about 35 kilometers. 90% of the Earth's ozone in the atmosphere is contained in the stratosphere. On here, you can see outer space. This is the limb of the Earth, which is the edge of the Earth. And then you have the troposphere, and then you have the stratosphere. So now we're at the upper reaches of the atmosphere. We're approaching 100 kilometers in altitude, and we're about to enter the realm of outer space. So as we travel out into space, we start approaching our nearest and dearest neighbor, the moon. The moon is 382,240 kilometers from the Earth. It took the Apollo 11 astronauts 3 days to reach the moon, and they were traveling at a velocity of 11 kilometers per second in the Apollo spacecraft. And actually that distance is about 10 times around the Earth. That going 10 times around the Earth is about the same distance as going from the Earth to the moon. If you were to drive your car or your motorcycle, and I would hope you would wear a helmet, because I have seen many people driving motorcycles here without helmets. If you were to do either, it would take you about 6 months to drive to the moon. And if you were to walk, it would take you about 9 years to walk to the moon. As we leave our moon behind and we venture out amongst the planets, that's called interplanetary outer space. That's the space that exists between the planets in our solar system. The distance from Earth to our sun is 150 million kilometers. Now, a million is 6 zeros, right? Yeah. So that's 150 with 6 zeros behind it. That's a big number, right? That's a big number. And that term in astronomy is called 1 astronomical unit, or 1 AU. That is the distance from the Earth to the sun. 1 AU, or 150 million kilometers. Our solar system, the whole width of our solar system, is 80 AUs. Because I want you to realize how large these distances are that we're talking about, I'm going to say do the math, okay? To get that amount of 80 AUs in terms of kilometers, you multiply 80 by 150 million. And that gives you the total kilometers of the width of our solar system. That's already getting pretty big, isn't it? Now, that's nothing compared to what we're about to go into. So in astronomy, the unit of kilometer is not a useful measurement of length because the distances are they're just too huge. So what's used is what's called the light year. It sounds like it's a measurement of time because of the word year, but it's actually a measurement of distance. Now, light seems like it's instant, right? You turn off the light in your house, or you turn it on, and it seems like it's instantaneous. But the velocity of light has actually been measured in the laboratory once we had equipment that was capable to measure something moving that fast. It actually has a velocity. And that velocity, the speed of light, is 298,000 kilometers per second. Not per hour. 298,000 kilometers per second.
I hope this isn't too many numbers.
That is the speed of light. So, 1 light year is the distance that a beam of light can travel in 1 year. Now, there's a lot of seconds in a year, right? We could say, okay, we'd start out by saying there's 365 days in a year. There's 24 hours in a day. There's 60 minutes in an hour. And then there's 60 seconds. 60 minutes in an hour, and then there's 60 seconds in a minute. So you multiply all those together, and that's how far a beam of light can travel in a year. This time I'll do the math for you. 1 light year is equal to, get this, 10 trillion kilometers. Okay? A trillion, that's 12 zeros. So 10 trillion is 13 zeros. So 1 light year, which is a measurement of distance, is 10 trillion kilometers. Okay, I want you to think about how huge that is. 10 trillion kilometers. That's almost even hard to imagine how big that is.
Seriously.
Our solar system, the nearest star to us, oh, actually, I want to mention something. So, our solar system is 80 AUs across. Now, the first human-made space probe to actually leave our solar system was Pioneer 10. It was launched on March 3rd, 1972, and it passed the orbit of Pluto on June 13th, 1983. It was traveling at about 300,000 kilometers per hour. And even traveling at that speed, it took 11 years for Pioneer to reach the edge of our solar system and head out beyond our solar system. 11 years.
Unreal, huh? Unreal.
Okay. So let's do like Pioneer 10 did, and let's leave our solar system and head out into what's called interstellar outer space. That's the outer space between star systems. Our solar system is one star system. There's many, many, many stars out there, just like our sun, that now that we have powerful enough telescopes to see out into space, we know that other planets orbit other stars, just like the planets in our solar system orbit our sun. So let's head out from our solar system. We were in interplanetary outer space, moving around between the planets in our solar system. Now we're going to leave our solar system and go into interstellar outer space. The nearest star to us is Alpha Centauri.
Couldn't find it.
It's on here, okay, it's on here. It shows our solar system. Okay, there's our sun. And then Alpha Centauri is, this has a lot of stars on it. Alpha Centauri is,
I still couldn't find it. Excuse me. Took a few
Okay,
seconds.
it's on here. Let me get to the main point.
Right.
Alpha Centauri, which is the closest star to us, is 4 light years away. So remember, a light year is 10 trillion kilometers. So Alpha Centauri, the nearest, the closest star to us, is 40 trillion kilometers away. 40 trillion kilometers. It takes a beam of light traveling at 298,000 kilometers per second 4 years to reach us from Alpha Centauri. Please excuse me, I may forget things that I want to say, and I feel it's important enough to say, so I just want to go back.
Nothing's changed, right?
This diagram. It takes light from the sun. It takes sunlight 8 minutes and 20 seconds to reach us. And it takes moonlight 1.3 seconds to reach us. Think about what I said about the distance. The distance from the Earth to the moon is 382,000 kilometers. It takes light 1.3 seconds to get to us from the moon. So when you look at the moon at night, the light that's entering your eyes actually left the moon 1.3 seconds before you saw it. And when we look at the sun, don't look at it directly, but the light from the sun, which is 150 million kilometers away from us, it takes sunlight 8 minutes and 20 seconds to reach us. I wanted to mention that earlier. Thank you. Okay, so back to Alpha Centauri, 4 light years away. It takes like 4 years to get to us. Okay, so now let's travel further out into space. Are you getting the idea of the enormous distances we're talking about? The distances that we deal with on everyday terms here on Earth, very, very minute compared to when you're talking about the distances in outer space. So let's leave our interstellar neighborhood and travel further out into space. Now, we're going to travel throughout our Milky Way Galaxy. Our solar system is right here. Now, notice, this shows our Milky Way Galaxy as a spiral galaxy, and we'll talk about that later. But think about it. Any picture, diagram you've ever seen of the Milky Way Galaxy, it's not a photograph. There has never been a spacecraft from Earth that has left has traveled out past Alpha Centauri and taken a picture of the galaxy. No space probe has left our galaxy and took a snapshot or even a selfie. No. So any diagram or picture you see of the Milky Way Galaxy is a diagram. It is not a photograph. Our Milky Way Galaxy, from one edge to the other edge, is, and this is where the distances start to just get ridiculous, if they haven't already gotten ridiculous, right? Between Earth, our sun, and Alpha Centauri. The width of our Milky Way Galaxy is 110,000 light years across. And let's just think about that one for a minute. 110,000 light years. So you got the number 110,000 with 13 zeros behind that. I don't even know what you would call that number. It's huge. I mean, I can't even imagine. It's beyond imagination, 110,000 light years. And one thing I wanted to mention is that notice where our solar system is located. It's not in the middle of the Milky Way Galaxy. If you think of the Milky Way Galaxy as a curve, we are not in the middle of town at all. We are way out in the sticks. We're not even on the main road, right? We're on a back road. We are not even close to being in the center of all the action. We're way out at the edge. So now, as we travel through our galaxy, which again is 110,000 light years across, we're in galactic outer space, which is the outer space that exists within our galaxy. Just like interplanetary outer space was the outer space between the planets in our solar system, and interstellar outer space is the outer space between the stars, between our sun and Alpha Centauri and the other stars. Galactic outer space is the outer space. Galactic outer space is the outer space that is in our galaxy, between all the stellar systems in our galaxy. There are as many stellar systems in the Milky Way Galaxy as there are stars in our galaxy, as there are planets around all the stars. It's just unimaginable, the distances and the amount of objects that are in outer space.
I may have misspoke on
you know
that.
The word infinite.
Intergalactic.
This isn't infinite, but these are huge, huge, huge numbers. So now, let's go even further out into outer space, into the unimaginable outer space of intergalactic outer space, which is the space between galaxies, right?
Okay,
You see how it gets
there we go.
bigger and bigger and bigger. First, there was the outer space in our solar system. Then there's the outer space
interplanetary,
between our solar system and the next star system and the other
interstellar,
star systems.
interstellar.
Then there's the outer space between those within the galaxy. Now we're talking about the outer space between galaxies.
Okay.
The nearest galaxy to our, here's our Milky Way Galaxy, and this is the Andromeda Galaxy, which is the nearest galaxy to us. The distance between these two, 2.5 million light years, okay? So you got a million, which is 6 zeros, and then you add trillion to that, which is 12 zeros. So when I say 2.5 million light years, I'm talking about 2.5 with 18 zeros behind it, in kilometers, okay? 18 zeros. I can't even think of what you would call that. That's just unreal, okay? So that's the nearest galaxy to us. Is everybody getting an idea of just how huge outer space is? Do you think we'll ever be able to travel such distances? No, not with our current mode of travel. No way. I mean, just to go from here to Alpha Centauri, which is 4 light years away, you would have to be able to live, I think maybe 1,000 years, something like that. So with our current mode of travel, it's no way. So, the Andromeda Galaxy mode of travel, it's no way. So, the Andromeda Galaxy and our Milky Way Galaxy belong to what's called the local galactic group. So you have all these other galaxies, our Milky Way Galaxy, the Andromeda Galaxy, and other galaxies that are further away from us, And together, astronomers have grouped them into what's called the local galactic group. Okay, we're already unimaginably far out there. We're gonna keep going. Our local galactic group, the nearest what's called a cluster is the Virgo cluster. So we have our local galactic group. Remember, our local galactic group was our Milky Way Galaxy, the Andromeda Galaxy, and other galaxies together in the local galactic group. Well, now as we keep going, we find out that there's other local groups. One is called, the closest one, okay, I keep saying the closest, is the Virgo cluster. The distance from the Virgo cluster to our local group is 54 million light years away. It just keeps getting more and more and more unimaginably ridiculous, doesn't it? 54 million light years away. 54 with 18 zeros behind it in terms of kilometers. And now we're going to go one more step. So we have the Virgo cluster is the closest cluster to us, to our local galactic group. These together with other clusters are called the Virgo Supercluster. Okay? The Virgo Supercluster contains our local galactic group, which contain our Milky Way Galaxy, the Andromeda Galaxy, and other galaxies. And then you have the Virgo cluster, and together with our local group and other clusters of galaxies, they form the Virgo Supercluster. So we're going to go one more step. The closest supercluster to our Virgo. Okay, once again, I forgot something that I wanted to say. So let me just go back.
And there we go again. Haven't changed, have I? One bit.
Remember that I said that the width of our Milky Way Galaxy is 110,000 light years across, and that's 110,000 light years. So what that means is a beam of light, which once again travels at 298,000 kilometers per second. And remember, it takes a beam of light 8 minutes and 20 seconds to reach us from the sun. And it takes a beam of light 1.3 seconds to reach us from the moon. Well, to go from one edge of our galaxy to the other edge, it takes a beam of light, because our Milky Way Galaxy is 110,000 light years across. That means it takes a beam of light 110,000 years to go from one end of the Milky Way Galaxy to the other end of the Milky Way Galaxy. 110,000 years for a beam of light that moves at 298,000 kilometers per second. Okay? So now let's go. So what I wanted to mention was, because the Andromeda Galaxy is 2.5 million light years from our Milky Way Galaxy, that means it takes a beam of light 2.5 million years to travel from the Andromeda Galaxy to our Milky Way Galaxy. 2.5 million years for light to travel. And in the same way, because the Virgo cluster is 54 million light years from our local galactic group, that means it takes a beam of light 54 million years to travel from the Virgo cluster to our local galactic group. And then now we're getting back to where we were. because it's 54 million light years from the Virgo cluster to our galaxy, or to our local galactic group. That means that it takes like 54 million years. 54 million years. Okay, so now we're back to where I was before I wanted to go back. Oh, yes, this is, yeah, the Virgo cluster is here. Our local galactic group is here. It takes like 54 million years to get from one to the other. Okay, and now the last step is what's called superclusters. The closest supercluster to our Virgo supercluster is what's called the Gamma supercluster. I don't know if you can take it anymore, but the
painful,
Gamma supercluster is
but
300 million light years away from us.
just to show what's out there.
300 million light years. So it takes a beam of light 300 million years to travel from the Gamma supercluster to our Virgo supercluster. Unbelievable distances, aren't they? Unbelievable. Well, I can't imagine those kind of distances.
Painfully so.
So now we have the observable universe.
We're almost done, everybody.
The observable universe. Now, according to the Big Bang theory of astrophysics, the universe is expanding. According to this theory, stars formed about 400 million years ago. The stars that we see. At this point, actually, I want to mention something. As you can see, I mean, think about it. Alpha Centauri is 4 light years away, so it takes like 4 years to get to us. But think about some of those stars that are in, for example, the Virgo cluster or the Andromeda Galaxy. They're millions of light years away. So that means it takes light millions of years to get to us. Some of those stars that we see at night, they are so far away from us, they're not there anymore.
Ghost stars.
They exploded millions of years ago. But we still see them because it took light so long to get to us. Think of Alpha Centauri, which is 4 light years away. Let's say Alpha Centauri blew up yesterday. Well, we would still see it because it's 4 light years away, so it takes light 4 years to get to us. So even though it blew up yesterday, the light is still coming towards us because it's going to take it 4 years to get here. But even more so, the stars that are millions and millions of light years away, long ago, thousands and thousands of years ago, they blew up. But we still see them because the light is still traveling to us. Think of 2 people that are on 2 hillsides at night, and one person has a flashlight. And let's say they're about 1 kilometer apart, and instead of traveling at 298,000 kilometers per second, let's say light travels at 1 centimeter per hour, okay? So instead of, it's really slow. So you have one person on the hill with the flashlight, they turn the flashlight on, and the light starts going at 1 centimeter per hour, so it's just eking out, right? 1 centimeter, then an hour later, another centimeter, and another. So the person on the other hillside, they see the light. They see, okay, that person's there, they're shining their flashlight at me. I see that. But now let's say that the person with the flashlight, they say, okay, I've been standing here for a while. I think I'm going to go home, get something to eat, relax. So they turn their flashlight off and they walk down the hill. The light that left their flashlight, because it's moving at 1 centimeter per hour, it's still going towards the other person. Even though the person with the flashlight turned it off and went home, the light is still going. So the person on the other hill, they think the other person is still there because they still see the light coming towards them even though the other person has left and gone home. That's what I mean when I say some of those stars you see at night are not there anymore, because light doesn't travel at 1 centimeter per hour. It travels at 298,000 kilometers per second. But those stars are so far away, as you saw, that the light is just now getting to us, even though they may no longer be there. Okay, so back to this. According to the Big Bang Theory, stars formed about 400 million years ago. The universe is expanding at a velocity of 68 kilometers per second. And according to this theory, the age of the universe is 13.7 billion years old. Now, we began this presentation with the question, where is outer space? Just as an island is surrounded by the ocean, our Earth, our planet Earth, our home, this island Earth, is surrounded by the vast, the unbelievably vast ocean of outer space. And I have a question that I'm going to leave you with. We began with a question. I'm going to finish up with a question. If, according to the Big Bang Theory, the universe is expanding, well, you know when you blow up a balloon, it expands, and it's expanding into the air, correct? We're blowing into it, and it's getting bigger, and it's expanding into the air. Okay, well, according to the Big Bang Theory, the universe is expanding. Well, if everything that we know exists, everything in creation is in the universe, then what is the universe expanding into? If everything that exists is supposed to be in the universe, and according to this theory, the universe is expanding, what is it expanding into? Okay, that was...
Okay, Ray, I continue on to a couple of questions. If you want to keep going, we can, or if we want to stop, we can stop. It's your call, brother. Your call, Ray. You want to keep the video going? It's got about maybe 10 more minutes. Oh, back to the video. Go
to find out about NASA.
Go back a little bit, Ray. Rewind it. Okay, there. That's cool. Thanks, Ray.
Okay, well,
thanks for accommodating me too, bro. Thank you. Thank you, Ray. You know I'll never go over like this again.
Everything in creation is in the universe. Then what is the universe expanding into? If everything that exists is supposed to be in the universe, and
I just wanted to make sure you could just stop it if you wanted to, bro.
What
Thanks,
is it
Ray.
expanding into? Okay, that was...
That's Wumi right there. The lady that I met here in Costa Rica, the educator, the science outreach educator, PhD.
At this point, we're going to take our lunch break. We have some food prepared for you. They will serve it. So, but I don't know if the
Very
video
cool
is ready.
person. Okay.
Go before 11 o'clock when we are supposed to change to another agenda of the item. Thank you very much.
Just wanted to give you an idea of some of the questions I got. It's awesome. It was awesome. Q&A.
Good morning, everybody. Good morning. What I'm going to pass around for you to look at while I'm going through the questions, because many people ask about how could they get into NASA or start to find out about NASA. I went through the same thing. Back in 1992, I moved out to California from Louisiana to try to get a job at the Jet Propulsion Lab, and I finally made it. So I'm gonna pass around my very first business card I ever had. And you'll see it's all beat up and everything because it's pretty old, but it's my business card from the Jet Propulsion Lab where I worked on the Galileo project. And then also, I'm gonna pass around my ID card from JPL. And then this is from the NASA Center in Huntsville, the Marshall Space Flight Center. This one, I was still a grad student, taking PhD level courses and doing research. And you'll see I was wearing my hair a little bit different style than I am now. But, so I want to pass these around, and part of the resource package that you will be receiving today will have my email address. And you can contact me at any time with any questions you have. We will stay in contact. So you will have my email address. So I'm going to pass these around. And then while you're passing them around, we'll get to these questions. Because concerning getting into NASA, I can send you information on the internships that are possible. There's some that exist now that weren't there when I was there, so I want to have full knowledge of what's available so that I can tell you information to help you proceed if you're interested in getting internships to NASA or to work there. There's 8 NASA centers in the United States. So we will do that. Okay, let's get to the questions. And as I read the questions, if I misread it, please let me know. Okay. How come we don't know how our galaxy looks while we know how other galaxies look? Okay. Remember, we can look out in the think of the moon. Remember how a long time we knew what the moon looked like, but we didn't know what the Earth looked like from the moon, right? That didn't happen until we had a spacecraft that could go out far enough to look back at the Earth. It's the same thing with galaxies. Especially with the space satellites we have, we can peer out into outer space and we can see other galaxies, but we have not had a camera on a space probe that has gone out far enough that it can look back at our galaxy. And as I was saying yesterday, when you look up at the sky and you see the galactic plane, that's looking from inside towards the middle of our galaxy. But in order to see our full galaxy, we'd have to be far enough outside of our galaxy to look back and see it. And the reason why we think our Milky Way Galaxy is a spiral is based upon data that we get from looking at the other galaxies. But the bottom line is, we don't really know what our galaxy looks like until we're able to go far enough out and look back and see what it looks like. How can we relate astronomy with microbiology? Do microbes exist in space, and to what extent? That's part of looking for extraterrestrial life. We have not as yet, to my knowledge, discovered any microbes in space, But just as microbes exist on Earth, I don't see any reason why they can't exist in space, because a lot of planets have atmospheres like the Earth does. Maybe we could not survive in an atmosphere that's mostly nitrogen or carbon dioxide, but that's not to say microbes can't. And actually, I want to, again, you'll be able to contact me anytime and ask me any questions, so don't worry if we don't get to all the questions. A lot of people want to know about extraterrestrial life. Now, the Earth exists in what's called the life zone, which means its distance from the sun is just right to enable us to live. If the Earth was a kilometer closer to the sun, or if it was a kilometer closer to the sun, it would be too hot for us to live. If it was a kilometer further from the sun, it would be too cold. We're right in the right place. And if something were to happen where the Earth would move closer for some reason or further, then it would not be good for us, but I don't think we have to worry about that. And also, when you talk about life existing out in space, remember, we think of life as what we know it. Those of you familiar with Star Trek, I forget which extraterrestrial says this phrase, but you know how we're referred to as the carbon life forms, or the carbon organisms. That's because all life on Earth is built upon carbon, oxygen, hydrogen. But now what if you have a planet where instead of oxygen, carbon, and hydrogen, you have carbon dioxide, silicon? There could be life out there that depends upon those elements, where if we were to come in contact, we wouldn't even know it's life, because we don't recognize that as life. The Curiosity on Mars could be rolling over all kind of life, but we don't know it as life because we don't recognize it as life as we know it. So keep in mind, as you've seen, conditions out in space are much different than here on Earth. But that's not to say that some form of life could not develop that depends upon other elements that we don't. Think about this. Think about this. As mysterious as outer space is,
How are you, Ray?
there's things here on Earth that we don't know about our own planet. Nobody has yet been down to the very bottom of the ocean. We don't know what's down there. We have not had a deep sea probe that could go to the very bottom of the ocean, because once you get that far down, the pressures are so intense with all the water above that either the electrical circuitry gets shorted out, or the hull of the probe can't withstand the pressure and is crushed. We have not had a probe that has gone to the very bottom of the ocean. We don't know what's down there. And you know how every now and then a fish will come up from the lower depths and get captured? Does it not look like an alien life form? It has a thick skin that can withstand the immense pressures. Doesn't have eyes, because you don't need eyes when you live in an environment where it's perpetually dark. They look like alien life forms, but they're Earth creatures just like we are. But they have developed in such a hostile environment as at the bottom of the sea that they look like they could be aliens, but they're Earthlings just like we are. So, and another place in Earth that we don't know about is at the middle of our planet. We don't know what's at the core of the Earth, because the deepest we've been in the ground is maybe, 5 miles. I don't think much further than that. That's nowhere compared to how far it is to the center of the Earth. We think that there's a molten core of metal because the Earth has a magnetic field is generated by an electrical current. So because the Earth has this magnetic field, we think that there must be molten metal at the core of the Earth, and because the Earth is spinning, this sets up an electrical current which generates the magnetic field around the Earth. But truth to tell, we don't know. We really do not know what's at the core of our Earth. So, as with space, there's a lot of mysteries out there that we don't know, and keep that in mind. So, when you're reading science books and you see the phrase that it's possible, or it is theorized, or it's hypothetically possible, that means that we really don't know. We really don't know. So again, you're training the students to find out, to one day find out, solve some of these mysteries that we still don't know about. Okay.
Thank you, Ray. That is okay. Thank you. So yeah, I had awesome questions from the teachers, and I would hope that at the conclusion of such a presentation to the Baduka community, I would get the same type of questions. So I know I have overstepped our time limit, and so again, this gives you an idea of what my intentions are of the kind of presentation to give to the Baduka community, to give them an idea of where the current science is with respect to outer space. And like I said, there's four other presentations that I would like to give them after the 15th of December. Now, where is space would be on the 15th, and then somewhere down the line, how do we view outer space from the Earth, which would have a big connection with the spheres. The spheres were used to observe the moon and the sun, objects in outer space. And then the other presentations, how do we get to outer space, what's in outer space, how does the environment of outer space differ from ours? Those would be cool to do as well. But we will establish a dialogue with the community so that as we continue, we'll tell them about what we know. They'll tell us about what they know. Okie dokie, everybody. Have an awesome week. Tune in next week. Same fat time, same fat channel.